This is Ms. Thomas's Algebra 2 Semester Exam Review Guide, 13-14 school year problems worked out. Starting with number 1, which is just a simple plug the numbers in for x and y and then solve with, please excuse my dear Aunt Sally. It tells you in the problem x is -3 and y is 9. So we're going to stick those into the equation. Watch your order of operations. Some people leave it as plus and negative. Some people make it -3. Just know from here, left to right, combine like terms. This will be -30 plus 30 will be 0. Number 2, same thing. M equals -2. We will replace m with -2. Lots of parentheses, but work innermost first. 3 times -2, that's going to be -6. Inside parentheses, continuing, gives you -8. Multiplying left to right, -8 times another -8 makes +64. Number 3, solving the equation. We want to get the variable on one side, numbers on the other. I'm just going to subtract the 8z to the left, subtract the 3 to the right, divide by -12. Z will equal, reduced, a positive, 4 goes into each 2/3. Next, number 4. You need to sketch a graph on this one, or not a graph, but a diagram of a rectangle. Identify one side as x. If the other side is 5 feet longer than wide, it's x plus 5. I know some of you did 5 times x, but it did not say 5 times as long as said 5 feet longer. Perimeter is 34. Remember, you add up all the sides. It may help you to label all of your sides. Add them up. X plus 5 plus x plus 5 equals 34. Combine your like terms. 4x plus 10 equals 34. And I know you can finish this off. Subtract 10, divide by 4. The question wants to know, what is the length of the rectangle? The answer is not 6, it's 6 plus 5. So 11 is the answer they're looking for, 11 feet. Number 5, graph. This is an mx plus b problem. You are going to plot b. Of course, you know I encourage you to use graph paper, but we want to keep this video going. Plot your b. The y-intercept. Our slope is positive, so you know ultimately it should be going up from left to right. Rise over run, up 5, 1, 2, 3, 4, 5 over 4, 1, 2, 3, 4. And plot that. You can make it a nice straight line if you use a ruler. Of course, we want to put arrows on the ends because the line goes on without ending. Number 6. It says to find the x and y intercept and then graph it. In our foldable On linear equations, graphing, the standard form that you see here enables us to find the x and y intercepts using the cover-up method. If I want to know the x-intercept, y must equal 0. So I can cover it up. And when I cover it up, I have 4x equals 36. If 4x equals 36, x is 9. The y-intercept, on the y-axis, x is equal to 0, so we can cover it up. It's going to go away. Solving negative 3y equals 36. I divide by negative 3. Negative 12 is the y-intercept. On the graph, on the x-axis, we put a point at 9. On the y-axis, at negative 12. And again, draw the line. Please be careful. This x and y intercept, those are 2 points. It's not a coordinate 9, negative 12. 9, negative 12 is down here, and obviously it is not on the line. Number 7, absolute value. Y plus 2 equals the absolute value of x plus 2. When you're graphing these, get y alone. Subtract 2 to the other side. And you have a foldable that gives us a shortcut on how to graph these. We need to know the shape. The shape is a V. In front here are no values. That tells me that the V, each side has a slope of a 1 and then the negative 1. Remember the shortcut we learned. Inside the bars moves the V left or right, opposite the sign. Out at the end, that is our up-down shift, same as the sign. So when we graph this, that is going to move it left 2. This one will move it down 2. Left 2, 1, 2, down 2. Plot that vertex. And again, this is why graph paper is handy. You will do a slope of 1 because that's what the number is in front. That only is true for absolute value. Make sure you don't try that on the parabola, the x squared, because that's not going to give you a parabola. 1 over 1, up 1 over 1, up 1 over 1. It will be going through the origin. And again, up 1 over 1, up 1 over 1. So your vertex helps to know, label it. Number 8. Graphing inequalities. Again, you can grab your linear equations foldable on graphing. Inequalities, you do the same. You just need to remember solid or dotted line and where do I shade. Starting here, we're going to plot mx plus b. B is 2. From there, we will do our rise over run. And we will rise to run 3. 1, 2, 3. If you were to fall off the graph paper, remember you can also reverse both directions and you'll still be on the same line. Instead of going up and right, go down and left. 1, 2, 1, 2, 3. And you are on the same line. This is a solid line. If the inequality includes the or equal to, it is a solid. If that little bar is missing, remember it's a dotted line. And shading. Greater than typically means to shade above, so we can shade above the line. The exception to that rule is if there were a negative in front of the y. But there's not, so we're good, as long as y is on the left. I know some of you prefer the test point. If you do a test point, a good option is the origin 0, 0. Plug 0 in for x and y. See if it's true or not. So that would give me 0 greater than or equal to 2/3 times 0 is 0 plus 2. Is 0 greater than 2? No. Since that's false, I would not shade where 0, 0 is. Instead, I would shade away from it, which satisfies the greater than being shaded above. Number 9, solve the system by graphing. You must have graph paper for this one. So, let's see if you can see this or not. If not, just let me know, and in class we can take a closer look at it. So you're going to need to graph both, because what we are doing here is wanting to find their intersection. Since the equations are in standard form, I prefer to do cover-up method. The first equation the x-intercept, that's this guy. We'll do him in one color. We'll do him in black, and we'll do the other in red. The black line's x-intercept is positive 6. 1, 2, 3, 4, 5, 6. And the y-intercept is 6/4. That's 3/2, which is 1 1/2. And it's okay that it's a half. I know you can plot that. So we draw our line, and it really is important to be accurate. A nice sharp pencil comes in handy here. I'm afraid my marker has me off, but we will see what happens. The second equation, the x-intercept, is 3. Plot that. So is the y-intercept. 1, 2, 3. Draw your line. And again, we are looking for the intersection point. And the lines should intersect. It looks like 2, 1. 2, 1 is what my graph looks like. And then, of course, you can confirm it by plugging 2 in for x, 1 in for y. If it satisfies both equations, it's the solution. And it will. And I'll let you test that on your own. Number 10. Keep that handy for another graphing question. See, graph. Is 5 - 2 a solution? Well, there's 2 ways you can go about doing this. Option A is to go ahead and just solve it and see what you get. Option B is to plug these 2 values in for x and y. If the point satisfies both equations, then it's a solution. So if I plug in x5 here and -2 here, I will have, and I know you can mental math this, we're checking those, 10 and a -12. That's -2, which is equal to -2. Check. It works in the first equation, but it has to work in both. One is not enough. Plugging into the second equation, 5 plus 2 times y, is that equal to 1? That's what we're wondering. That's -4. 5 and -4 is 1. Check. Since it satisfies both equations, it is a solution. Yes. All right, for the next group of questions, it's going to load on a different video. So